Welcome back students to the part 2 of today's session. Let us discuss about the addition of vectors. There are two laws for vector addition. The first one is the triangular law of vector addition. If two vectors are represented both in magnitude and direction by the two sides of a triangle taken in the same order, then the resultant of these vectors is represented both in magnitude and direction by the third side of the triangle taken in the opposite order. If two vectors, vector A and vector B, are to be added, then according to the triangular law of vector addition, we have to draw vector A as it is and move vector B parallel to itself so that it touches the end or tip of vector A. When the head of vector B is connected to the tail or tip of vector A, and if a vector is drawn from the starting point of A to the ending point of B, then vector OQ given in the figure will represent vector R, which is given by vector A plus vector B. The second law of vector addition is the parallelogram law of vector addition. You all are familiar with a parallelogram. If two vectors acting at a point are represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, then their resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. Just refer to the figure. Suppose if vector A and vector B are the two given vectors. So, join the heads or the starting point of the two vectors together. Then draw a line parallel to A starting from the end point of B. Similarly, draw another line parallel to vector B starting from the ending point of vector A. These two will meet at a common point. Draw the resultant vector from the joining point of vector A and vector B to the opposite corner of the parallelogram, which represents its diagonal. In the figure, vector R represents the diagonal or the resultant of addition of vector A and vector B. Coming to the subtraction of vectors. Subtraction of a vector B from a vector A is defined as the addition of vector minus B or the negative of vector B to vector A. In short, we can say vector A minus vector B is equivalent to vector A plus minus of vector B. Coming to the properties of vector addition. Vector addition is commutative. That is, vector A plus vector B is equivalent to vector B plus vector A. Vector addition is associative. That is, vector A plus vector B plus vector C is equal to vector B plus vector C plus vector A is equal to vector C plus vector A plus vector B. Also, vector addition is distributive. That is, m into vector A plus vector B is equivalent to m into vector A plus m into vector B. Resolution of a vector into rectangular components. Here, a vector A in any arbitrary direction is changed in the form of two vectors, one along the x-axis and another along the y-axis. If any vector A subtends an angle theta with the x-axis, then the horizontal component, that is the component of vector A along the x-axis, is represented as A cos theta. From the figure, it is clear that cos theta is equivalent to adjacent side AX divided by hypotenuse A, or AX is equivalent to A cos theta. Similarly, vertical component AY is equivalent to A sin theta. Suppose if you are taking sin theta from the figure, sin theta is opposite side by hypotenuse. Opposite side is actually AY. So AY divided by A is equivalent to sin theta, or AY is equivalent to A sin theta. Suppose if you are given a vector A in any arbitrary direction, then the magnitude of this vector A is equivalent to square root of AX square plus AY square, where AX and AY are the components of A along the X and Y directions. From the figure, tan theta is equivalent to AY by AX. So resolution of a vector means splitting up of a vector into two directions, one along the x-axis and another along the y-axis. Hope you have understood about the addition of vectors and also resolution of a vector. Thank you, dear students.